Hello, math students. Today we're going to be going over a lesson from writing linear functions and equations. We're going to be doing the tutorial, the practice, and the mastery test. So go ahead and write down everything I write, do everything I do, follow along closely, and I promise it'll make a lot more sense that way. I know these videos are long, but if you take your time and practice, I guarantee you'll do much better and you'll understand it much more. Okay, so try not to skip ahead, just follow along. It'll make a lot more sense. All right, I'm on page 5 of the tutorial and let's go ahead and get started. It says we have two situations. In Lakeville, Melinda's television cable bill is a flat rate of $50 per month plus $1.50 for every movie she rents. After 1 month, her service bill is $66.25. So the equation that would kind of go with this one here, with situation 1, would be like the amount of her bill, which is $66.25. This is for situation 1. She's charged $1.50 times the number of movies she rents, plus a flat rate or a constant $50. Okay, so you can see this would be the equation from the first situation. And in this case, you would be able to solve for X if you wanted to. You could find the number of movies she rented that month. This is situation 1, once again. Situation 2, let's see, it says in Oceanside, Kimberly's television cable bill is a flat rate of $60 per month, plus $1.25 for every movie she rents. So here, they don't give us what the output is, but it tells us that she's charged $1.25 times the number of movies, plus a flat rate of $60. So for the second situation, we can't solve for X here or we can't find the value of X because they don't give us the value of Y. So in this question, it asks us if you were to model these two situations with equations to solve for all unknowns, what similarities and differences would the equations have? So one thing you could say is that in the first situation, you have one variable missing, the number of movies. But in the second situation, you have two variables missing, the number of movies and the final price. Can you solve for all unknown in both situations? No, we can't. We can solve for X in the first situation if we wanted to. But here we have X and Y in the second situation, so we can't find the value of either of them really, okay? So those are that's what you want to write here. And if you want to, you could use the equation editor to write the equations as well. I briefly explained what you should put, so go ahead and basically put that down in your own words. Once you're done with that, let's go ahead and move along. And essentially, a lot of this unit is going to be knowing these 3 forms of linear equations. Now, if you were watching my video from the last section, you should know these 3 forms, especially the slope-intercept form. The slope-intercept form is the one you're going to be using the most. Y equals mx plus b. This is what you'll see the most. The point slope, or the standard form, usually looks like this. AX plus BY equals C. And generally speaking, in this standard form, A, B, and C are not fractions, okay? So it's all like integer numbers, like 5x plus 7y equals -20 or something. So you wouldn't have like 1/2 x in the standard form. And then point slope form, we did go over that in the last lesson as well. So I guess I'll use a different color here. This one was y minus y1 equals m. M is the slope. It's the same as the m in the slope intercept. X minus x1. So this last equation requires a point, a coordinate point, like an x and y coordinate points, and the slope in order to write its equation. Okay, so these are the 3 main linear equations you're going to need to know. And I would say the most important one by far is the slope-intercept form. Okay, this is the easiest form if you're looking to graph the line. And that should be the one that you kind of take the most effort to try to memorize, I would say. Okay, so let's go ahead and use these forms and let's figure out which of these equations are in various forms. So first, slope-intercept form, y equals mx plus b. So it needs to be in the form y equals, and then mx plus b, that would be this one here. In this one's example, the slope, or the m, is 2/3. Meanwhile, the y-intercept, the b, is 17. Standard form. So which of these are in standard form? Well, this one would be in standard form here. Here your A is 6, your B is -3, and your C is -51. Lastly, point slope form would be this one. Okay. This one also looks like point slope form, but remember you have to have y on the left side. So yeah, this is an example of a slope-intercept form. This is an example in standard form, and this is an example in point slope form. Okay. The graph of a line goes to the point -4, 3 and 6, 8. What is the equation of the line in slope-intercept form? So slope-intercept form, that's the y equals mx plus b form, okay? And we want to go through the points -4, 3 and 6, 8. So the first thing you're going to want to do is you're going to want to find the slope, find the m. Now, how do we find the slope? Well, remember, that's the rise over run, rise over run. Hopefully you remember that. To find the slope of a line, that's its rise over run. So how do we find the rise? Well, to find the rise, you subtract the y values. So when you look at these 2 points, what we want to do is subtract the y coordinates. So that would be the 8 minus 3. So the y coordinate from this one minus the y coordinate from this one over the run. So it's rise over run. So the rise, we look at the y coordinates. The run, we look at the x coordinates. So this would be 6 minus -4. This gives us 8 minus 3 is 5. 6 minus -4. So that's the same as 6 plus 4, which is 10. So you should always simplify fractions if you can. In this case, you can simplify this to 1/2 because dividing both top and bottom by 5, 5 is a factor of both these. So 1/2 is your slope in this case. Now we have our m. Remember, our form is y equals mx plus b, our slope-intercept form. So now we know our m, it's 1/2. So y equals 1/2 x, but we don't know b yet. So I'll just continue to write b for now, but we want to figure out what that b is. I hope you're writing down everything I write because that'll help it make a lot more sense. Now, how do I find my b in this case? Well, I'm going to use one of these coordinate points. You can use either point. It doesn't matter which one you choose. I'm just going to go ahead and pick this second point though, 6, 8. And they're going to use that point to help us find b, the y-intercept. So I'm going to replace the x with 6 and the y with 8. So how does that look? Well, I'm replacing the y with 8 equals, this will be 1/2 times x, and the x in our case is 6. We still have a plus b. Make sure not to, sometimes I confuse my b with the number 6, so just be careful not to do that. My 6 and my b kind of look similar. Anyway, this becomes 8 equals, well, what's half of 6? Well, that's 3. Then we still have a plus b. Let's go ahead and finish solving for b. The way we're going to do that is by subtracting 3 on both sides of the equation to help us get b by itself. Now we know b. Now we know the y-intercept. So our equation is y equals 1/2 x, so our slope is 1/2 still, plus, and our b is 5. So y equals 1/2 x plus 5. So let's go ahead and put that in. 1/2, 1/2 plus 5. Okay. Go ahead and move along until you get to this page right here, page 20. That's where it'll stop you. Let's go ahead and read this question real quick. It says, George rented a cab for his family for a day of sightseeing. The cab company charges $9 to pick up his family from the hotel and 25 cents per mile for the trip. If X represents the number of miles and Y represents the total amount George pays, select the equation and the graph correctly modeled by the situation. So here we're going to find our equation in the slope-intercept form. So that's the y equals mx plus b. So there's two things we need. We need the m and we need the b. Generally speaking, this is actually pretty easy here. Notice it says you're charged 25 cents per mile. That means you're charged 25 cents every mile. So 25 cents for the first mile, another 25 cents for the second mile, another 25 cents for the third mile, and again and again. So this repeated part is going to be your slope. And I know this because what's essentially happening here is that 25 cents is multiplied by the number of miles driven. X is the number of miles driven, right? See, it says X represents the number of miles. So that 25 cents is multiplied by the number of miles. So for example, if they drove 20 miles, it'd be 25 cents times 20. B, the B or the y-intercept is the constant amount. So this is the amount, a flat rate, basically. Now you're charged a flat rate of $9 plus the 25 cents times number of miles. So this is your equation here. Y equals 0.25x plus 9. Okay, hopefully that makes sense. Generally, if it says you're charged a certain amount per something, or that's going to be usually something that's going to get multiplied by a variable. So in this case, multiplied by x. Now let's figure out which of these graphs correctly show that equation. Well, let's take a look. Our y-intercept should be 9. So this one has a y-intercept of 9, and so does this one. But which one is correct? Well, one thing to keep in mind is this 0.25. If you want to write it as a fraction, which generally that's easier for us to graph if it's in fraction form, well, that's 1/4. So 1/4 is the same as 0.25. So I could write, if I wanted to, I could write this as y equals 1/4 x plus 9. Then it's easier to graph it in a way because our slope is 1/4. So we rise 1, run 4. Rise 1, run 4. So let's go ahead and look at our graphs. Is this one correct here? Well, let's see. Our y-intercept is 9. That's good. But the slope looks like it's a slope of 1. Rise 1, run 1. Rise 1, run 1. See, that's not correct. It's actually going to be this one. Notice rise 1, run 4. Rise 1, run 4, creating this less steep line. All right, let's go ahead and move on to page 25. That's where the activity starts. In this activity, you will model, okay, blah, blah, blah. Okay. Unanswered, unanswered. Okay. Jessica has $24 and plans to spend it at the grocery store, spend it all at the grocery store. She wants to purchase bags of carrots and bagels. Okay. Bags of carrots cost $2 each and bagels cost $3 per bag. Let X represent the number of bags of carrots and Y represent the number of bags of bagels. Complete the equation in standard form and models this scenario. Okay, I don't know why she wants to buy just carrots and bagels, and I don't know why she wants to spend all of her money on that, but whatever. This is the scenario. It's $2 times the number of bags of carrots, right? Because it's $2 for a bag of carrots. So it's $2 times the number of bags of carrots. Well, X is the number of bags of carrots, right? X represents the number of bags of carrots. So $2 times X, whatever that amount is. Whereas $3 per bag of bagel, so that's 3Y, where Y represents the number of bags of bagels, equals the total amount she's spending, $24. Now we want to write this in slope-intercept form. So right now our equation is in standard form. So we want to rewrite it in slope-intercept form. You can see this is standard form, right? 2x plus 3y equals 24, standard form. But I want this in slope-intercept form, which is y equals mx plus b. So this is what we're looking for, y equals mx plus b. Now, how do we do that? Well, we just need to solve for y in this equation. So first thing we're going to do to help us solve for y is subtract 2x from both sides of the equation, canceling it here on the left, giving us that 3y equals negative 2x plus 24. Lastly, to help us get y by itself, we're going to go ahead and divide by 3, canceling this 3. But since I divide the left side by 3, I have to divide the right side by 3 also. Notice that when I divide by 3, I have to divide every term in the equation by that 3. So we've got negative 2/3 x plus 8. Y equals negative 2/3 x plus 8. And you're going to go ahead and put that here. So y equals negative, use the fraction tool, 2/3 x plus 8. And there you go. Here your slope is negative 2/3 and your y-intercept is 8. So if you were to graph it, you'd put the y on the y-axis, you'd put a point at 8, and then you'd go down 2 over 3 because the slope is negative. If Jessica decides to buy 4 bags of bagels, so in this case, the y-coordinate they're saying is 4, she will be able to buy blank bags of carrots. So we're going to go ahead and I'm actually going to use this standard form equation here. So this one right here, the 2x plus 3y equals 24. And we're buying, how many bags of bagels did they say? 4 bags of bagels. So our y value is 4, essentially. Now I could use either equation, but I'm going to go ahead and use this form right here. You could use either equation. You'll get the same answer either way. But the bagels represent y. So this is going to be 3 times 4 because she's buying 4 bags of bagels. And we're going to figure out how many bags of carrots she'll be able to buy. Okay. So this gives you 2x plus 12 equals 24. Now we're going to go ahead and solve for x. And the way we're going to do it is subtracting 12 on both sides of the equation. Remember, whatever you do on one side of the equation, you have to do the same thing on the other side. 24 minus 12 is 12. Divide both sides by 2 in order to get x by itself, giving us that x equals 6. So if she buys 4 bags of bagels, she'll be able to buy 6 bags of carrots. Let's go ahead and graph this line. And I already kind of described how it would go, so see if you can do it on your own. But if you're having trouble, no worries, I'll go over it. So we have y equals negative 2/3, so negative 2/3 is our slope, it's a negative slope, so it'll be going downward as you go from left to right. And our y-intercept here is 8. So on the y-axis, we're going to put a point at 8. And that's because the y-intercept is 8. Then from there, from that point, we're going to use our slope to help us. So we're going to go down 2 over 3. Down 2 over 3. And you should see that if you continue down this pattern, notice the points all line up. That's good. That's what we want. So we could just draw that just like that. And there you go. Okay. Well, now that you're done with that, the main thing I want you to know, and maybe you should definitely write these down, is these 3 forms, the slope-intercept form. And make sure to show that the m is the slope, the b tells you the y-intercept. Then you have ax plus by equals c, that's standard form. And standard form, the a, b, and c are all integers, meaning whole numbers. And then lastly, point slope form. M, once again, is your slope. And then the x sub 1, y sub 1 come from a coordinate point. Okay. All right. Well, with that, let's go ahead and move on to the practice. And you're going to be given 5 questions for the practice. And I have 10 questions here. You're going to be given a sample of those 10 questions. You'll be given 5 questions, but I'm going to go over 10 questions. If you just follow along, do everything I do, and pay attention, I promise you'll do well. Okay. A tire warehouse has an inventory of 100 tires. Customers can only purchase tires in complete sets of 4. So you have to buy 4 at a time. You can't buy 1 tire. Create and graph the solution set to the equation for the remaining amount of tires, y, in terms of the number of sets of tires purchased, x. So our equation is going to be y equals. Now, the thing we're starting with, so starting amount of tires is 100. Okay, because it says start with 100 tires. And now when people come to purchase tires, they're purchasing them 4 at a time. So we're losing 4 tires times the number of customers, x. Okay. So we have a y-intercept of 100. So on the y-axis, I'm going to put a point right here at 100. Then our slope is -4. We could think of this as -4 over 1. So we'd go down 4 over 1. However, this graph is a little bit tricky because I can't just count down 4. Because if I count down 4 from here, you can see it's actually counting by tens, right? Like the next line down is actually 90, then 80, then 70, then 60, right? So it's not just counting 1, 2, 3, 4, it's counting, 10, 20, 30, 40, right? So, how do I deal with this? Well, one thing I could think of is I can go down 40 over 10. So I could basically increase the size of this fraction by a multiple. And it's essentially the same slope, or it is the same slope actually, because this still just reduces down to 4 over 1, right? So I could think, okay, well, I'm going to go down 40 over 10. So from here down 10, 20, 30, 40, but then I have to go over 10. So I'm going to go all the way out to here. And then we can use our ray tool to create our graph. Question 2. Emily is 280 miles away from home. She is traveling back at a rate of 40 miles per hour. So 40 miles per hour, that means 40 miles times the number of hours. So x is the number of hours. Determine which graph and which equation represent Emily's distance from home D after she has traveled h hours. So they're actually not even using the variable x. Instead, they're using the variable h for hours, which makes sense because she's traveling 40 miles times the number of hours, right? 40 miles per hour. That's what that means. Now, she's currently 280 miles away from home, but she's driving back home, right? So she's 280 miles away from home, but she's coming back towards home, back at a rate of 40 miles per hour. So the distance she is from home is 280 miles to start, but then she's closing the distance by 40 miles per hour. Okay. So which equation is that? Well, we should see a y-intercept of 280. Okay, so that's either this graph, maybe. I'll put a dot for the maybes. Or maybe it's this one, because this one also has a y-intercept of 280. Okay. I know which answer it is down here. It's going to be this one. Here they switched where the negative 40h and the 280 are, but that's not going to trick us. Okay, but it's one of these ones. Now I want to go down 40 over 1 is our slope, right? So here, down 40 over 1 from 280, that'd be down 40 to 220 over 1. That doesn't seem to line, this one doesn't seem to line up very well. What about this one? Down 40 over 1. Yeah, that seems to line up pretty well, right? So when I went from 280 to 240, I go over 1 hour. So that seems like that's the correct answer. Okay. Question 3. Ben purchases 2 drinks and a popcorn at the movie theater for a total of $9.50. If X represents the cost of the drinks, and I'm guessing this is a Y, Y represents the cost of the popcorn, which equation represents this situation? So about 2 drinks and a popcorn for a total of $9.50. X represents the drink. So about 2 drinks plus a single popcorn for $9.50. I don't know what theater he's going to, but I feel like that's pretty cheap for what theaters usually charge. Now notice all my equations are in slope-intercept form. So I'm going to move from this equation to slope-intercept form. So I'm going to subtract 2x on both sides of the equation to get the y by itself. Y equals negative 2x plus $9.50. There we go. Next one. Carly is traveling to visit family. She drives X miles on the first day and Y miles on the second day for a total of 800 miles. So the amount she drove on the first day plus the amount she drove on the second day add up to 800 miles. What is the domain and range? Well, for the domain looks at the possible X values. Well, what are my possible X values? And then the range looks at the possible Y values. So what are my possible Y values? Well, for the domain, the lowest amount that she could possibly have driven on the first day is 0 miles. The largest amount she could have possibly driven is 800 miles. I would say the range is the same, right? So the amount she drove on the second day is somewhere between 0 and 800 miles. Okay, we know in total these X and Y should add up to 800, but it's possible she drove all 800 on the first day and then 0 on the second day, right? Or vice versa. So I would say our domain and range would be this. Okay. What's the difference between this one here and the last one? Well, the last one basically says that X and Y can also be negative, right? Which we don't want to say that. Okay, question 5. The graph shows the number of books Y Melissa read during the weeks of summer break. X. She also read several books during the school year. Okay. Determine the equation that can be used to represent this situation. So we just want to find the equation for this line. So it's Y equals and we're going to do mx plus b. So we want to find the slope, and we also want to find the y-intercept. Now, the y-intercept is pretty simple. We can see it. I'm actually going to use green here. The y-intercept is right here. So that's our b. Now, what is this value here? It looks like it's between 12 and 18. So what number would be there? Well, looks like it's counting by threes. Each little dash is by 3. So this would be 15 here. Okay, so our y-intercept is 15. So that's our b. Okay. Now, what's our slope? What's our rise over run? Well, let's see. It looks like a rise here, run, rise, run. Okay, so how much are we rising? Well, don't say 1, because remember, these dashes actually are counting by 3. So it's rise 3, run 1. Rise 3, run 1. That's our slope. So y equals 3 over 1x plus 15. 3 over 1, you could just write it as 3. So y equals 3x plus 15. Okay. In other words, she's reading 3 books every week. My goodness. That's a lot of reading. All right. Now, this one, we also want to find the slope-intercept form for these set of points. Well, one thing you could do is actually they give us the b for free. It's actually right here. 1. The b is 1. Now, how do I know that? Well, if you think about a coordinate point on the y-axis, so maybe the point's like right here, it's always 0, something. And that something is the y-intercept, right? Because that tells you where it crosses the y-axis. Any coordinate point on this line is 0, something. We covered this more in the previous lesson. Well, notice this, it's 0, 1. So that tells me that this line goes through 0, 1, which means that that's our y-intercept, 0, 1. So that's our b. Our b is 1. Easy peasy. Now, I want to find the slope. So in order to find the slope, or my m in this case, we could use any 2 coordinate points. I'm going to go ahead and use maybe these 2 right here. And you could use any 2 coordinate points. They don't even have to be next to each other. And what we want to do to find the rise over run, or in other words, the slope, to find the rise, you subtract y values. To find the run, you subtract the x values. So here, for our rise, we can do 4 minus 1, subtracting the y values, 4 minus 1. And in the denominator, we'll do 1 minus 0, 1 minus 0. So this gives us 3 over 1, which is 3. So the slope for this is 3. So y equals 3x plus 1. Was equation for a line that passes through the points 5, -3 and -10, 15. So once again, we want to get into the slope-intercept form, y equals mx plus b. And how do I know I want this form? Well, that's because all my answers are in that form. Okay. But if my answers were in a different form, I would, not use this form. Okay. But anyway, let's go ahead and find our slope. Find our m. Once again, that's the rise over run. So to find the rise, we subtract the y values. So here I'm going to do 15 minus -3, subtracting the y values here. Then in the denominator, it'll be subtract the x values. So -10 minus 5. Now, 15 minus -3, that minus negative makes it a plus. So this is the same as 15 plus 3, which of course is 18. Over -10 minus 5 is -15. So negative. And I could reduce this fraction. I could divide both these by 3, actually. Divide the top by 3, divide the bottom by 3 to give us -6/5. And again, it's negative because a positive divided by negative is negative, okay? It doesn't matter that the positive is bigger or anything like that. A negative divided by a positive, different signs, always makes negative. So our slope here is negative 6/5. Okay, so it's either this one or it's this one. In other words, is my b -3 or is my b 3? Well, I could use either of these coordinate points to help me find my b now that I have my slope. I'm going to go and use this first point here, 5, -3. So I'm going to replace the x with the 5 and the -3 with y. So in my equation, I'm replacing the y with -3, and I'm replacing the m with -6/5 because that's our slope, and I'm replacing the x with 5. And then we have a plus b. I'm trying to find the b here. Now, we have -3 equals, how do I do -6/5 times 5? Well, I know it's a negative times a positive, so I know that'll be negative. Now, in order to multiply a whole number times a fraction, I've explained this in other lessons too, but to multiply a whole number times a fraction, you multiply the whole number times the top, then divide by the bottom. So 5 times 6, then divide by 5. So 5 times 6 is 30. 30 divided by 5 is 6. So we have -6 here. Then we also have a plus b. My goal is to figure out what b is. So let's go ahead and solve for b in this equation. To solve for b, I'm going to add 6. Then that forces me to add 6 on the other side of the equation to keep it balanced. -3 plus 6 is +3. This cancels, and that leaves me with b. So what's my b? What's my y-intercept in this case? 3. So that's this one. -6/5 for the slope, and then a y-intercept of 3. Was the equation a line that has a slope of 1? So our m is 1 and passes through the point 1, 5. So here, all my answers are in the point slope form. So just to remind you, the point slope form is y minus the y coordinate equals the slope times x minus the x coordinate. You get your x coordinate and your y coordinate from the point here. Okay. So what's our x sub 1 is 1. Our y sub 1 is 5. And our m is 1. So what's this going to look like? Well, let's go ahead and replace y sub 1 and x sub 1 and m with the values here. So y minus y sub 1 is 5 equals m is 1, parentheses, x minus x sub 1. X sub 1 is 1. Multiplying by 1 doesn't actually do anything, so this one in this case is not necessary. An architect needs to consider the pitch or steepness of a roof in order to ensure precipitation runoff. The graph below shows the vertical height y versus the horizontal distance x as measured from the roof's peak support beam. You can see in this case, the y-intercept, the b, is 10. That's where our line crosses the y-axis. Well, what's our slope in this case? Well, I hope you can see that our slope is actually going to be negative because we're going down as we go from left to right. We can use any of the other coordinates to help us out here. I might use this coordinate. I'm going to use this coordinate point here. So what's my slope? To go from this y-intercept to this next point, we would go down 1 over 2. Down 1 over 2. So what's that slope? our rise was down 1, and our run was over 2. So our slope is -1/2. So which of these equations has a slope of -1/2 and a y-intercept of 10? That's this one. Last one. Charlotte is on the yearbook committee. She starts the semester with 5 page layouts done and completes the layouts for 1.5 pages each week. Which graph represents the number of completed pages, y, after Charlotte works for X weeks? So here we're going to have y equals. Now, how much is she completing each week? Well, it says 1.5 pages each week. And X is the number of weeks. So it's 1.5 times X. Usually when you see per or for each, that's going to be your slope in a lot of cases. Your y-intercept is usually your starting amount. It says she starts the semester with 5 pages. So that's going to be our y-intercept, our b. Y equals mx plus b. Slope is 1.5. Y-intercept is 5. So which of these have a y-intercept of 5? Well, not this one. This one does. So I'm going to put a little dot for maybe. And this one does not. So maybe it's that one, or maybe it's this one. Okay. Now we're going to use our slope to help us. Well, 1.5 is our slope. So we can think of it as rise 1.5 or 1.5 and then run 1. That's kind of a pain. Another way to look at this is actually, this is a fraction 3/2. So you rise 3, run 2. Let's see, is that this one? Well, from 5, if I rise 3, that puts me at 8, and then I run 2. Yeah, that seems to work. What about this one? From 5, if I rise 3, that puts me at 8, and then I'd have to run 3. So that doesn't seem to work here. So it must be this one. Well, that's it for the practice. Let's go ahead and get started on the mastery test. Now, by the way, you're going to be offered 5 of these questions. I have 20 questions here. You're going to be offered 5 of these questions from this bank of questions. Again, just follow along. I'll give you at least a hint for each and every question. And if you find this useful, please like, comment, subscribe for the algorithm. Okay, it's just a small way you could say thank you. Let's put it that way. All right. Jackson has a gift card for $120 to use at a department store. He wants to purchase 2 shirts and 3 pairs of pants with the gift card. If X represents the cost of the shirts, Y represents the cost of the pants, what are the domain and range? So in our case, we have this equation essentially. 2x plus 3y equals 120. In other words, 2x because the shirts costs, or because he's buying 2 shirts, and 3 pairs of pants, that's 3 there. Okay. X represents the cost of the shirts, Y represents the cost of pants. What are the domain and range of this relationship? Well, they can't cost less than 0. And let's take a look at, let's say he only buys only buys shirts. Well, then there would be, Y would be 0. So 2x equals 120. If he only buys shirts here, then x equals 60 because I'm dividing by 2, dividing by 2. So the x value is between 0 and 60. So that must be this one here. Okay. Angela is driving across the state to her friend's house. She just filled her fuel tank to its maximum capacity of 26 gallons. If the amount of gas in her car decreased by 2 gallons every 48 miles, which of the following graphs best represent the number of gallons of fuel remaining? So let's see, Y equals, she loses 2 gallons every 48 miles. So she loses 2 gallons every 48 miles. This is your slope. The starting amount is 26 gallons. Why did I put a negative here? Well, because the car decreases or loses 2 gallons of gas every 48 miles. So which of these has a y? You need a y-intercept of 26 and a slope of -2 over 48. Well, you could actually reduce this slope a bit too, right? This is actually -1 over 24. If I divide by 2, reducing my fraction. So for every time I go down 1, I need to go over 24. This is a little bit tricky because here it's counting by like 4s here, right? So what if I go down 4? So here I'd have to multiply by 4 if I want to increase this. And multiply this by 4, giving us -4 over 96. So if we go down 4, we should go over 96. Well, this one doesn't seem right. How about this one? If I go down 4, that puts me here. I go over to 96. That seems correct. Let's graph Z here. I don't know why it's A graph W, B graph Y. They should just be A graph A, B graph B, and so on. But, what do I know? Sam and his mother made an agreement for the upcoming weekend concerning internet usage and watching television. The function on the graph below represents this agreement they made. Okay. So let's take a look. Hours of watching television, 10. Hours of internet, 5. So it looks like, to me, this is a lot of TV, but it's basically saying he could watch, if he just watches TV, then he could watch 10 hours of TV if he does no internet. So he could have 10 hours of TV with no internet, because this point is 10, 0. And then, or he could do 0 hours of, whoa, I messed that up. This is 0, 10. So he could do 10 hours of TV with 0 hours of internet. Or another option, he could do 5 hours of internet with 0 hours of TV, right? And he can go somewhere in between, right? So like he could do, this point represents 2 hours of internet and 7 hours of TV, right? 2, 7. All right, let's see which of these make the most sense. Sam will always spend more time watching television than on the internet if he follows his agreement. No, not necessarily. He can choose how he uses his time. Sam watching television for 10 hours and spending no time on the internet. I think he could do that, right? That makes sense. Sam spending 5 hours on the internet and no time watching television. Oh, okay. I didn't read the question. It says, what does the x-intercept represent? So it's talking about this point right here. So this point represents having 5 hours of internet and no TV. Which of the following is a linear equation, corresponds to the table above? Okay, so this right here gives you the y-intercept. So we know our b. We're going to write our equation, y equals mx plus b. This gives you your b right away. And then to find the slope, you can use any 2 coordinate points to find the slope. I'm just going to use these last 2 here. To find your slope, you would do m equals, and then you would subtract the y coordinates, so 43 minus 31. And then the x coordinates, subtract those on the bottom. So go ahead and work this out. This gives you m, and then this right here gives you b. A farmer stores hay in his barn to feed his cows and uses the table to monitor the hay remaining in the barn. Okay. All right, I can see my y-intercept right here. So I know my b, my y-intercept is 60, which graph represents the number of bales in the barn after feeding his cows for X days. Okay, well, I know it's not this one because it has a y, this one has the wrong y-intercept. Then what you would do is find the slope. So the slope, actually, you don't need to do that because right here it gives you the x-intercept. So one thing you could look for is this gives you the x-intercept as well. So that's where it crosses the x-axis. And this tells you where it crosses the y-axis. So figure out which graph shows these coordinate points. Marjorie bought a new car with some miles already clocked on it. She kept track of the miles she put on her new car each day, as shown in the graph below. So it looks like she started with 150 miles. And how many miles is she adding each day? So what's the rise versus run? So what's the slope, basically? Okay, figure that out. The graph of the linear function given below. What is the zero of the function? So here they're using a term that you may have not have seen before, but here it says, what is the zero? In this case, the zero is the same, a zero is the same as your x-intercept. So it's asking, what is the x-intercept for this equation? So again, the x-intercept is where your line crosses the x-axis. So figure out, looking at this, where's the x-intercept? Where's the zero? The equation of the line is in point slope form. Okay, so we can see the point slope form here. Remember, the point slope form is y minus the y coordinate equals the slope x minus the x coordinate. So what's the slope in this case? A line passes through these two coordinate points. Write an equation of the line in standard form. Okay. Well, one thing you could do is just check each of these solutions and see which one of these solutions works for these coordinate points. Okay, so let me show you what I mean. So I'm going to go ahead and try these coordinate points for answer choice A. So I'm going to replace the x with 10 and the y with 5. So this would say 3 times 10 minus 5. And I want to see, does that equal 5? Well, let's check. So again, I'm replacing x and y with 10 and 5. So this is 3 times 10, replacing the x with 10, minus 5, replacing the y with 5. And I want to see, does that equal 5? So this would be 30 minus 5. Well, that does not equal 5. So this one's definitely not correct. The correct answer, the one that is correct, will give you a true solution for this and for this. So find out which equation would work for both of these coordinate points. What is the equation line that goes through these two coordinate points as well? So this one's exactly the same as what we did for the last one. So you can just plug in the points to see which one of these equations gives you a true statement for both of these. Okay, so you'd replace the x and the y with these coordinates and see if it works. So let's go ahead and try this answer choice A. This would be 3 times negative 3. Again, replacing the x with the x coordinate, plus 2 times negative 1 equals 15. Well, that gives you negative 9 minus 2 equals 15. Well, negative 9 minus 2, that's definitely not 15. It's negative 11. So that means this is definitely not correct. The correct answer will give you a true equal statement for both coordinate points. So whichever one's the correct answer will give you a true equal statement for both coordinate points. The production of health drink cans at a warehouse can be represented by the equation below, where X represents the hours of production and Y, the total supply of items in the warehouse in hundreds. Y equals 3/5 X plus 2, which the following graphs represent the situation. Well, we know our Y-intercept is 2. So it's definitely not this one. This one has a y-intercept 2, so I'm going to put a dot for a maybe. This one has a y-intercept of 2, so does this one. But this one right here is actually wrong because this one has a negative slope. See how it's going down? Well, it's definitely not a negative slope. We should have a positive slope. So which of these shows a slope of 3/5? So that would be a rise of 3, run 5. Or is it this one? Rise 3, run 5. Okay, figure that out. Was the equation aligned as a slope of -4 and goes through the point -1, 6. So here we're writing our equation in point slope form. Your X sub 1 and your Y sub 1 are right in here. And your M is right here. So this is a little bit tricky, but when you do this X minus X sub 1, this will be X minus, and then your X sub 1 is -1. So this part right here will become X plus 1. Just keep that in mind. Okay, and then plug in the rest and see which one is correct. 13, Sarah's hiking on a trail near her home. She traveled 5 miles before stopping for a break. After the break, Sarah plans to increase her speed to 3 miles per hour. Which equation models the total distance D Sarah can travel after hiking an additional H hours? So the starting amount, right, where she stopped for her break, this is your y-intercept. And your slope is her rate afterwards. Okay, see which one of those correctly shows that. Heather paid $2,022.30 for a computer. If the price paid includes a 7% sales tax, which of the following equations can be used to determine the price of the computer after tax? Let X represent the cost of the computer and Y represent the total cost after tax. Okay. This is kind of an odd one, but this is the one you want to do. This is D, because a 7% sales tax basically means that your price ends up getting multiplied by an additional 7%. The X is your price of the computer. So the 1 represents the price itself, and then the 0.07 represents an additional 7% on top of that. I didn't think that last one was very fair. Okay, Andrew is counting the total calories in his breakfast. He knows that a bowl of his favorite cereal with milk has 200 calories. He also likes to drink a fruit smoothie with his cereal. Each ounce of smoothie adds 25 calories. Which graph represents total calories, Y, in Andrew's breakfast if he drinks X ounces of fruit smoothie with the cereal? So here we're going to have Y equals, so the number of calories equals. Now for the smoothie, it's 25 calories each ounce. So for each something or per something, that's going to be your slope. And your starting amount is 200 calories. So he's eating the cereal's calories doesn't change. Okay, figure out which of these shows that correctly. Well, one thing I'm just going to help you out with this. One thing you need to look at is first your y-intercept needs to be 200. So this one has a y-intercept 200, so maybe it's this one. This one's wrong. This one does not have a y-intercept 200, and this one does. So it's either A or C in this case. Now my slope is 25, so that means I'd rise 25, run 1. Well, here it's kind of hard to see by 25. So maybe instead of 25 over 1, maybe I want to think about this as I can multiply this by 2, multiply it by 2 to make it bigger. So 50 over 2 maybe. So I could rise 50, run 2. So from here, rise 50, run 2. That doesn't seem to show here. Here, rise 50, run 2. Rise 50, run 2. Yeah, that seems right, because this is like 250 here, right? A linear function has a y-intercept of -12 and a slope of 3 over 2. What is the equation of line? So you want to write your equation in y equals mx plus b, slope intercept form. In this case, your slope is 3 over 2, and your y-intercept is -12. Select the correct answer. Let's take a look. Which equation describes the graph above? Well, let's take a look. First of all, your y-intercept is right here. Looks like at -3. And also we have a negative slope, it looks like. If I go from this point to this point, it goes down 3 over 1. So your slope goes down 3 over 1. So what would that slope look like? And your y-intercept is -3. So what would that look like? Mr. Jensen is a salesperson for an insurance company. His monthly paycheck includes a base salary of $2,175 and a commission for $250 for each policy he sells. Okay. Write an equation in slope-intercept form that represents total amount Y in dollars of Mr. Jensen's paycheck in a month where he sells X policies. Do not include dollar signs in your equation. So in this case, you're going to be writing your equation in y equals mx plus b form, so slope-intercept form. Your slope in this case is the amount he earns per sell, so his commission. So this is your m, and this is your b. The starting amount, this part, this constant doesn't change, so that'll be your y-intercept. A barrel in Jim's yard contains 60 gallons of water. Water leaks out of the barrel at a rate of 1 gallon every 10 minutes. Create and graph the solution set of the equation for the gallons of water Y remaining in the barrel in terms of the number of minutes elapsed X. So again, we want to be in slope-intercept form. Our starting amount is your B. So in our case, our B is 60. And then the water leaks out at a rate of 1 gallon every 10 minutes. So it loses 1 gallon every 10 minutes. So our slope, since it loses 1 gallon every 10 minutes, is -1 over 10. So what would that look like? Well, we know our y-intercept is 60, so that'll be a point right here. Now, down 1 over 10, it's hard to go down 1 in this case because it's counting by tens, right? So how am I going to go down just 1 and then over 10? So one thing I could do is I could increase the size of this or increase these numbers by multiplying by a common number here. I'm going to go ahead and multiply these by 10. Well, why by 10? I'll show you. So that's going to be down 10 over 100 now. And the reason I'm going by 10 here is because these are going by 10 here, right? So I can go down 10 over 100, and that'll give me my line. In this case, you can't go below a certain amount. So this goes like this. Once you've gotten to this point, you can't go below 0 gallons, so it doesn't go on to the negatives. So you want to, instead of using the ray, go ahead and use the line segment tool. The line segment tool. Okay, because the ray with the arrowhead, when you see lines, I just want to state this real quick. When you see lines with the arrowheads, that means it continues on forever in those directions. But we don't want to indicate that because the barrel will not leak forever. It has a stopping point, and that's when it has 0 gallons, right? All right. Last question. A jetliner uses 3,600 gallons of fuel per hour while it is cruising, and there are 15,000 gallons of fuel in the jetliner's fuel tank when it begins to cruise. All right, so its starting amount, I'm guessing that's our B, it's our y-intercept. It uses, or in other words, loses, so I'm going to say negative this many gallons per hour, so over 1. If y represents the amount of fuel in thousands of gallons remaining in the fuel tank after the jetliner cruises for X hours, determine the graph, the solution set for this situation and the equation modeled by the graph. Okay. So our equation is going to be like this one here. And generally, this is our answer. Generally, I want to write that 3.6x, the mx first, and then plus b. So our y-intercept is 15, and our slope is negative 3.6. So see which one of these graphs shows that the best. Okay. Well, with that, I hope you found that helpful. Hope you're able to get through this lesson without too much pain. If you'd like to say thank you, just subscribe, or better yet, share my channel and its content with someone else who would find it useful. All right, well, with that, take care. I'll see you guys next time. Thanks for watching.